All right. So for today,
She's not on.
oh, thank you. The last couple of assignments you have, or I should say the last equations you have to learn. I did put on Huron's formula up there. I'll describe that quickly. Seniors, you don't have to do that. That's not on this current homework.
We don't have a test yet, do we?
I don't know. You might.
I
Yeah.
have a question. So the seniors have to do the right triangle one and then the two.
And this one today.
Okay.
Anything after that, I'll post, but you don't have to do them.
So anything after the law.
Law of sines and law of cosines.
Okay.
So you could just use this week to, do those. If you finish all your stuff by next class, you can use that time to study for other finals.
Okay.
There won't be a test for you guys in here. So the last couple of equations, I got 3 on the board there. You can see kind of in the middle to the left of the crucifix, there's the law of cosines. There's 3 versions of it. I'll explain that in a minute. On the right side of the board, you'll see law of sines. There's a couple ways you can write it. It's the same law, but I just wrote it a couple of different ways. And the last one there on the right is Huron's formula. Hopefully, I'm not sure about law of sines and law of cosines, but I would assume that you probably saw Huron's formula in geometry class, hopefully. So I'm going to explain all those today and then go over how you would use those in problems. You have, I think, 9 problems on this last assignment for seniors. All right, so to go over those really quickly, Huron's formula, these are just formulas. So Huron's formula, my pen is really fat. This is for finding, I'll write it. So this is for finding the area, and so all of what we're doing now today works for triangles in general. They don't have to be right triangles. So they don't have to have a 90-degree angle in them. This will work for any sort of obtuse or acute triangle. And they also work for right triangles. So the assignments up until today were for right triangles. The assignment today, and Huron's formula isn't on the one today, but I'll describe it. These work for triangles in general, so not just right triangle. All right, let's say you have a triangle. And you've got the 3 sides, A, B, and C. We can define something called the perimeter. So the perimeter is A plus B plus C. That's the distance around the triangle. Hopefully you remember that from geometry. That's the perimeter. We can also define something called the semi-perimeter. Now, a semi-truck has half the wheels. Semicircles, half a circle. A hemisphere, with an H, is half a sphere. Semi actually means half, so the semi-perimeter is actually the perimeter, A plus B plus C, cut in half. So it's half of that. And that's what we call the semi-perimeter. Huron's formula is pretty basic. You'll just calculate your semi-perimeter, S, which you just add up the sides and divide by 2. And then if you want the area of any triangle, just take the semi-perimeter, multiply by the difference between the semi-perimeter and a side. Actually, you do the semi-perimeter minus every side. And then you square root that. Shh, quiet, please. So this is Huron's formula. It's pretty straightforward. If you have all 3 sides, add up the sides, divide by 2. And then just take that number times that number minus one of the sides, that number minus the other side, that number minus the other side. Multiply them and square root, and that's how you can calculate area pretty straightforwardly. This isn't on any homework yet, but it's just a formula it's good to know that it exists. So if you have all three sides and you want the area, you can do that with this formula. Any questions on that? Okay, I'm not proving it, but I did post a video where they kind of prove it, how you get this formula. If you need it, just know that it exists and you can use it. All right, so for today we have law of sines and law of cosines. This will work for triangles that we don't know, that aren't right triangles. So a right triangle, of course, has a right angle. It looks like this. We know that a squared plus b squared equals c squared for a right triangle. I'm going to write it a slightly different way, actually. I'm going to write that in backwards a little bit. So a squared plus b squared equals c squared. And I'm writing it kind of with the c on the left. And that's for right triangles. For all triangles, so not just right triangles, we have what's called law of cosines. So this was Pythagorean theorem. And this is law of cosines. And it is that a side squared is equal to the sum of the other two sides squared minus twice the product of the other two sides times cosine of the angle opposite to the side on the left. So if I had something like this, so it's not a right triangle, you'll notice. If I look at that angle in the corner, I know that I can relate the three sides with any angle using law of cosines. So this is one version of it. Now, it just so happens that when C is 90 degrees, when that corner is 90 degrees, cosine of 90 degrees is 0. So this term would go away in that case, and you would just have the Pythagorean theorem. So the Pythagorean theorem is actually the law of cosines in the special case where one of the angles is 90. But if it's not 90, you can use the full expression to, that should be a plus. Just like you would use the Pythagorean theorem, the only difference is you need an angle. Now the law of cosines always applies, so if you're looking at little c here, and it's opposite to that angle C, the little c goes on the left side of the equal sign. The other two sides get squared and added. And then you subtract twice their product of the other two sides times cosine of big C. So the big angle goes with the little side to the left of the equal sign. So if this is C, that's C. Now there's other versions for this, works for all the other angles. So if I wanted to find a relationship with angle A, I'd have to put the little a here, the other two sides squared and added together, minus twice the other two sides, times cosine of the angle opposite to this A. And you can build the other one. If I want to find angle B, I would take B, side B squared, the other two sides added together, the square of them, minus twice the product of the other two sides, cosine of the angle opposite B. So these always, let me do that a different color maybe. These always kind of go together, the thing on the left and the angle. And the rest of them are the other two sides. So that's law of cosines. If you have three sides, you can find an angle. If you have two sides and an angle, you can find the other side, even if it's not a right triangle. That's your law of cosines. It's just a formula. And you just sort of plug things in and then solve it. And then that's pretty much it. Just a nice law for you to use when you're solving triangles. It's a pretty good one.
Only do that for triangles?
You would use that. You don't have to use this if you have a right triangle. You can use what you already know. If you have a triangle that's not a right triangle and they're asked to solve it, you can use this to go beyond what the right triangle stuff would give you. So, on the left,
Because of the right, you already know the angle of it.
yeah, you know that one of the angles is 90. And so, like, if you look up there on the right, if you can see that, c squared equals a squared plus b squared, that is the Pythagorean theorem, which is what it is for right triangles. It's just if that big C isn't 90, if it is 90, this term makes 0. But if it's not 90, you need a correction factor in there. So when it's 90 degrees, you just have the Pythagorean theorem. When it's not 90 degrees, you have an extra term. Yeah. All right, so you've got a few problems they're the last few problems on the homework that involve law of cosines. The first few involve what's called the law of sine, so I'll go over that one now. Okay, law of sines is kind of intuitive, in my opinion. You have, just like how I said that if you have like a flashlight with a narrow beam, like a small angle, it will make a small spot on the wall. And if you have a flashlight with a wider beam, it'll make a big spot on the wall. And likewise, we said that in a triangle, the smallest angle will open onto the smallest side. The second largest angle will open onto the second largest side. And the very largest angle will open onto the largest side. So the bigger the angle, the larger the side that it opens onto. Now, you would think that, yeah, you might think that that the ratio between one side to the other, so if I call this A, this B, and this C, then the angle that opens onto A I'd call big A. The angle that opens onto side B I'd call big B, and the angle that opens onto side C I'd call big C. Now, we do know that the bigger the angle gets, the bigger the side gets. So you might want to think in your head that, okay, well, the ratio of side A to side B is equal to the ratio of angle A to angle B. They're proportional. Well, that's actually not quite true. It's not a linear relationship like that. The true statement is that the ratio of side A to B is equal to the ratio of the sine of the angles. And so that's one way of expressing what we call the law of sines. The ratio of the two sides is equal to the ratio of the sine of the two angles. Now, some people write it differently. So some people will do kind of like cross multiplication here. They kind of flip these two things. So a lot of times you'll see it written like this. So, or you could write it sine of A over A equals sine of B over B. So the ratio of the sine of an angle to the side is the same for all the pairs on the triangle. So this is just an equivalent way of writing the law of sines. It doesn't matter which way you like best, which way you're used to seeing, they're the same. One thing I'll mention, though, is when you're trying to solve a triangle, I'll do another triangle over here. So we've got side angle A Angle, I'll call this, well, let me do that differently. I'll call this B, A, B, and C. I'm trying to go smallest to medium to large. All right, so this would be side A, side B, and side C. Now, it's good to think of the pairs of angles. I'll do the symbol, I guess. Angles, sides. So you have pair 1, pair 2, and pair 3. So for angles, you have A, you have B, and you have C in the triangle. And for sides, you have the corresponding sides, little a, little b, little c. Now, so for solving a triangle, you need pieces of information from each pair, pretty much. So you could have, 3 sides. Let me go to green here. You could have the sides, and you could figure it out. You could have the angles. You kind of need a side to figure out a triangle. So you could have any of the sides and 2 angles. Yeah.
Can I please use the restroom?
Yes. You could have an angle and 2 sides. But you kind of need one from each pairing. So that's one thing to watch out for, to know if you can even solve the triangle or not. You got it? There's one special case I'll mention, and I did post a video about it. I did not intend to put one on the homework, so hopefully you don't have that on the homework. But there is a special case called the Ambiguous Case, and you'll see that there's a video added to the YouTube playlist that explains that to you, just in case it pops up early. I did not mean to put it on the homework, but I don't know if it will pop up just through the random number generator. But there's a special case where Law of Sine will give you trouble solving the triangle. The issue is that if you have some sort of triangle and you don't know how the triangle looks, so you got one side that goes kind of somewhere, you don't know how long it is, maybe the base is this long, maybe the base is this long, you're not quite sure, you're not given that information. So you don't know how long the base is. You do know one of the sides is, I don't know, A, and one of these this angle is B. You're given those 2 pieces of information, and you're also given that the side opposite to the angle B is some length long. So let's say it's not a right triangle. This would make a right triangle. But if you're given a length B for that other side, and it's longer than this, if it's longer than that length, then you don't know if that side comes this way or if it comes this way. So you're not quite sure if this angle is this wide or this wide. These are the same length of sides, but you can orientate it either way, depending on the unknown, which is how long is this thing? Is it that long or is it that long? So that's called the ambiguous case. When you use Law of Sines and you use your calculator to solve it, your calculator, when it calculates this angle, this will be angle C, it will calculate the smallest possible option. So if you try to do your calculator, it's going to assume that this is your triangle. That may not be your triangle. You may actually have the bigger triangle. So just be aware that if you have an angle, a side adjacent to that angle, and a side opposite, you probably are in the ambiguous case. And so it might be better to try law of cosines, or try it both ways. Try with the smaller angle, and then realize that it could also be if you take the complementary of that smaller angle, so let's say this is 30 degrees. Well, that means there's 60 degrees missing from the 90. This could be 60 past 90, not 60 under 90. So your angle could be either 30 degrees or 150 degrees in the ambiguous case. It's one of those. You're not sure. The calculator will tell you 30. But if you have angle side, then you're in the ambiguous case, and you don't know if that other angle up here is 30 or 150, because you don't know this side. You don't know how big it is. So you're going to have to use other clues that are given in the problem. You might have to do it both ways and see which one works out with your problem. So, go down two different paths. Maybe it's 30 degrees. Let's see what that triangle looks like. Maybe it's 150. We'll see what that triangle looks like. But just be aware that there is a case where we call the ambiguous case, where if you just plug it into the law of sines, you get an answer on your calculator, and you use that, you might still get it wrong, because there's a special case where you kind of got to do a little bit more thinking and make sure that all the information you're given checks out with the triangle that you've drawn. So this triangle is either an acute triangle or it's a obtuse triangle. You're not sure. Hopefully you don't have that on this first assignment. I tried not to put it on there yet, but just be aware that it exists. All right. So we will go into some of these. Okay, this picture is not drawn to scale. They label some things, and they have this little scenario of two radar stations on the ground here. They are located 75 kilometers apart. So this base here, B, is 75 kilometers. I'm going to draw this, so if I have to redraw it, you know what it all says. All right, they're 75 kilometers apart. The angle of elevation measured by the one on the left is 86.5 degrees. And the angle of elevation measured on the right is 83.2 degrees. They want to know how far is the UFO from station A, and how high up is it? So we don't know where exactly to split this distance B to make the right triangles. So we're probably going to have to deal with the law of sines or law of cosines. So I'm going to draw this again. Let me write all these angles: B, H, C, and A. Okay. This is alpha. That was gamma. Okay. Okay, we've got a triangle. The angles were alpha, beta, and gamma, the first three Greek letters. Your sides are A, B, and C. There's a height that we want to know. They tell us that alpha is 86.5 degrees. They tell us that gamma is 83.2 degrees. They tell us that side B is 75 kilometers. So what can we figure out? Well, I know beta already if I wanted to know that, because these angles have to add up to 180. So I've got 80 over here with 3.2 extra. So if I put that 3.2 with this 86.5, I'll get 89.7. So 100 minus 89.7, because if I took 80 off, give me what, 10.3? Is that right? I believe so. So beta, yeah, must be 10.3 degrees. That's just to make sure they add up to 180. But I don't really need to use that. What I have is I have a side, B. I have an angle, 86.5, and I want to know this side, C, I believe. So that is side, angle, side. That should not be the ambiguous case. So I think I can use law of sines just fine. I'll write side, angle, side. Using law of sines, I could write it one of two ways. I'll do it both ways just so you can see it. I could say the ratio of the sides. So C is to be what the angle sine of 83.2, that's the angle opposite to C, is divided by the sine of the angle opposite of B, which is 10.3. So I guess I did have to use it. That's one way to do it. So the ratio of the sides is equal to the ratio of the sine of the angles that open onto those sides. Is this setup okay? You guys okay with that? B in this case is 75. So C must be 75 times the ratio of sine of 83.2 divided by sine 10.3. The other way to do that would be to do sine of one angle. So sine of 10.3 divided by 75 is equal to sine of the other angle. And then if you rearrange that to for C, it gives you the same expression. So C should be approximately equal. Let me see what I get. So I got, would that be right? Yeah, I guess it has to be right. 416.5072175. That's pretty big, but also remember that angle beta is like 10.3 degrees, so that's a very small angle, and that should open onto the smallest side. So if the smallest side is 75, then this other side should be quite a bit bigger than that. So that seems to make sense to me. So let's see what we get for that one. Any questions on that? Let me check that. And that's what we got. Good, good. Now they want to know the height. So if we got 416 point, let's see if it'll take that. I'll just say 5.1. It took that for that first part. Now we got to figure out the height. So you have, let's look at the right triangle now. I know that this is 90 now. This is 86.5. This is now 416.51. And I don't know this thing up here, but I can subtract, 90 minus 86.5 to find that. Is that 3.5? So I should be able to come up with the height. Actually, I don't even need that. I can just use, I have opposite over hypotenuse. That should be sine. I'll do 507 just to give me an extra decimal. And so h should be 6.507 times sine of 86.5. We get about, really? I guess so, 415.73. Yeah. So I would put in yes. I just make sure that you put in a few extra decimals. That way you have enough precision. We'll try question 2. I'll draw this so I can redraw it in just a second. Okay. Okay, so finally, so we have just, I'll draw that a little differently. We have a very small angle on the right. It's just 11 degrees. We have a 59-degree angle here. We don't know x, but we know this is 12. This must be the smallest angle, so 12 must be the smallest side. So they want to find x. Well, we have two angles, and we want to find a relationship between two sides. So we can use law of sines. So x is to 12. And these kind of go together. X is to 12, what sine of 59 is to sine of 11. Well, those ratios should be the same, so x should be 12 times the ratio, sine of 59 over sine of 11. I got 53.9074-ish. So I just took the ratio of the sides equal to the ratio of the sine of each angle. And I got the correct answer. Just a reminder, most of these homeworks problems have videos that go along with them, so if you're attempting these later, there are those videos as well as the ones I posted to the playlist. All right, the question 3 gives you 2 angles and a side, kind of like the last one, except the side that we have is actually opposite to a side that we're not, I'm sorry, an angle that we're not given. But because we know the angles have to add up to 180, if I just do 180 minus 80, I get 100 minus 48, is that 62 or 52? That should be the other angle. So I can figure out angle C, or you could use law of cosines here. No, I'm sorry. You need another side. So yeah, we'd use law of sines since we have 2 angles. So yeah, we have 52 as sides, angle C, and 208. Let me draw this. 80, 52, and 48. We know that, there we go. Okay, to try to get them, I'm going to do kind of like a big angle, kind of close to 90 degrees. That's going to be my 80-degree one. Then I've got like a in-between angle that's about 60, a little less than 60 degrees. And I should make another angle that's a little smaller than that over here. So that's about 52 and 48 degrees. This was the one I had to calculate by subtracting the other 2 from 180. And we're given that side, so this is angle C. So we're given that side C is 208. So this side should be bigger than 208. And this side over here should be smaller than 208. So we already have an intuition about how this thing should look. So I guess what were they asking? Find side C, no. Find side B, side B. Which one was B? B is opposite of 48. So this is B, the little one. All right, so B is to, I don't know, 208. What sine of 48 is to sine of 52. These should be numbers that are close. B should be a little bit smaller. Times that ratio. Oops. I got about 196.1574. Can I calculate that? Okay, so hopefully law of sines makes sense to you. It's just a formula that you got to plug into. Just make sure that you understand the convention. I'll write it out real quick. You have sides A, B, and C typically. Those go with either angle A, angle B, and angle C, or you might see them go with side angles alpha, beta, and gamma. So if they're using Greek letters, it'll be alpha, beta, gamma for your first 3 angles. If they're using, whatever these Latin symbols, A, B, and C. Capital. I'm going to jump to law of cosines. Let's see if I can get one. So question 8 says use law of cosines. They want us to find this side x. Okay. So we have, I'll draw it again. You have an angle. You have two sides and you want to find the other side. This is law of cosines. Now it's a lot like the Pythagorean theorem. You have one side, x squared. I'm choosing that because it's opposite to the angle 46. X squared is equal to the sum of the squares of the other sides, 11 squared plus 22 squared. And then subtract the product of the other two sides. That product gets multiplied, I'm sorry, twice the product. And then multiply that by cosine of the angle opposite, so cosine of 46. So it's just following the convention that the side opposite the angle gets squared over here on the left. You make that equal to the other two sides squared and added. And then from those, you subtract twice the product of the other two sides times cosine of that opposing angle. So I would get, this is like 121 plus 144 minus, what is that? 484 times cosine of 46. Is that 22 times 11 times 2? Yeah, 484, okay. So if I take 121 plus 144 minus 484 cosine of 46, I got a negative 7, forget the sign, I guess. Not right, yeah, I think I did that right. 71.2147-ish. It was negative, but I'm just going to take it down as positive. And then I have to square root that. Where's my button? That's about 8.4388777372. So about 8.44. Let's see if I got that right. Negative's kind of throwing me off. No. That didn't seem right with the negative. What did I do wrong? Let me just double check my formula there. Twice, yeah, that's right. Let me just run those numbers again. Plus 2 squared minus, oops. Yeah, I did something wrong. All right, I'm not sure what I did. What I wrote was correct. Somehow, this is correct. Somehow, when I calculated it, I didn't do it right. So if 11 squared is 121, yeah. Oh, I didn't do 22 squared. I did 12 squared, which is 144. So that 144 is incorrect. That's what I did. I see. That should be 484 also. Okay. Is that okay? I just did this in my head wrong. So 11 squared, you square that, plus 22 squared, minus twice 11 times 22 times cosine of 46. All that should be correct. I ended up actually getting for x squared 268.7853487. And if I square root that answer, I do get 16.3946744. So just don't make mental errors like I just did. And you should get the correct answer. Let's see, it wants it to 4 decimal places. Just make sure you round properly. We'll do another one, but that's law of cosines. I'll do another one since I kind of made a mistake there. Well, that's pretty much the exact same thing. So this one, you have the 2 sides. So x squared will be 16 squared plus 14 squared minus twice 16 times 14 times cosine of 36. That gives me 89.56. If I square root that, I get 9.464, which is the correct answer. Questions on that? All right, we worked through a few of those. Some of them you're gonna have to set it up. You might have to do 2 triangles to figure it out per problem, but most of those hopefully shouldn't be too hard. You guys can work on that for the rest of the time. Let me know if you have questions. Oh, that's great. I wasn't presenting while I was recording all that, so it just has me and my voice and none of my writing. Awesome. I'll record next class's lecture, so you'll be able to look off the next class.